Thank you all for coming here. It's been phenomenal, your support, feedback, and questions through the week for all these sessions. And we are coming to the grand finale. We are talking about all-up monitoring. As the title says, it's monitoring, diagnosing, and debugging with Azure networking. What we're going to do today is a 400-level session. What it really means is that we are going to be starting with a fairly introductory set of information, and then we'll be peeling the onion, and we'll start talking about real-life customer problems that you face, and how do you really have the levers and the artifacts to go fix these problems. We also have two guests with us. One guest is from Gigamon. He's going to talk about GigaView platform, which just debuted in Azure this week. It's going to be a great success. And we also have someone from Gelata. So let's say you deploy an application that's globally distributed. It's across multiple regions. Now, how are you going to diagnose and debug problems in a situation where there is no time synchronization and so on and so forth? A very complex problem to solve. But I think this company is trying to make it very seamless and simple for you. What does a network look like in Azure? Here's a sample network. It basically is deployed across multiple regions, and you've got peering done across the regions. You also have an on-prem connectivity. You also have a connectivity to the internet. And it's basically composed from various resources that we have in networking, right from virtual networks, NICs, subnets, public IPs, load balancers, application gateways. You put all these individual software abstractions together and build your end-to-end network. This is what you see as your network, unlike your on-premise world. It's a bunch of resources pulled together. What does it mean for you when you have a slow website? What does it mean for you when your internal workloads in a virtual network are accessing malicious sites? How do you diagnose? What do you need to access to diagnose? That's very important. So you start from byte count. You want to have insights to packet level. You want insights to flows. You want insights to endpoints, circuits, tunnels, sessions, routes, security rules. You basically need unfettered access to all these artifacts. And how do we make them available to you? So, like I said earlier, an Azure network is primarily comprised of resources, individual resources that are bonded together and orchestrated together to create an end-to-end view. So we have two levels of monitoring and diagnostics available in Azure. One is at a resource level, where you have access to diagnostic tools for resources, metrics, counters, events, resource health, and so on. So at any point in time, you'll be able to go to a resource and figure out what is really happening to that resource. Or you could do it at the scenario level. Now you have a file server that is sitting on a VM behind a load balancer. You don't want to go and look at about 100 VMs and figure out what's happening. You want to say that, hey, I'm not able to access my file server. What is happening to me? I want to be able to go capture some packets on my file server. What's happening there? I want to investigate more. So at a scenario level also, we provide you a lot of artifacts to go debug and diagnose issues. And we also have a fantastic third-party integration, and you'll see shortly the list that we have. It's quite phenomenal. So let's dive deeper a little bit. I want to go into resource-level monitoring, what it really means. So we have a lot of resources, like we said earlier. Let's talk about resources that are helping you to connect to the on-premise world, primarily VPN gateways and ExpressRoute. You have fantastic insights to what amount of bytes are going out or coming into the circuit, or likewise for the tunnel. You can get the throughput. You can get resource health view of the tunnels and circuit. You'll also have reasons of why a tunnel is down, what are the contributing factors, and so on and so forth. So that's as far as the on-prem connectivity goes. This is just at the resource level. I've not yet gone to the scenario level monitoring yet. Let's talk about access to the internet. You could go through public IP, or you could work via an application gateway, a layer 7 load balancer. You need to know what amount of bytes are coming in or going out. If it's a layer 7 load balancer, you want to know what are the access that is happening. So access to access logs is good. Error logs is very important. If you have a 400 error, you want to know what's happening there, and so on and so forth. Now, within your virtual network also, the primary defaulters are, you misconfigure a security rule, right? You have effective rules that you can go and check what rules are configured on a subnet or a NIC. You can also find out what routes are available and so on and so forth. So you do have an end-to-end view of, or rather in-depth view of resource level monitoring as well. So you could go to a resource and you could dive down to details to understand what's happening. We debuted something called Network Performance Monitor. It's primarily a synthetic transaction monitoring capability. What it does is you have an agent in the VM. You also have an agent that is deployed in the on-prem, and we exchange probes. And as we do this, we also collect the data. We collect the data to provide you some insights, deeper insights into what is your availability over a period of time, what is your connection in terms of what throughput you're getting, what is the latency, and so on and so forth. And if there is a problem, you will be able to localize to a problem as well. Interestingly, we will also give you a topology view. This is all self-discovered. This is as far as Network Performance Monitor is concerned. We also have a new service that we released quite recently. It's called Network Watcher. Network Watcher is basically your genie in the cloud. Now, you have a problem somewhere, and you want to understand where the problem is, you just use Network Watcher. And we've got various pillars in Network Watcher. We've got topology. So you deploy something into the network, and you want to know what the topology looks like. You can access topology there readily. You have a suite of diagnostic tools. You have monitoring capability from Network Watcher itself. You have logs that you can enable, and I'll talk about that shortly, and also analytics. So let's say you deploy 100 VMs into a network, right, a virtual network, and each of them has a NIC. So imagine trying to figure out how these JSON objects are connected to each other and how they are associated to each other. That's not going to be scalable, that's not going to be possible as well for you to diagnose. If you want to readily go and understand what rule is applied on a given NIC, it's again a scalability problem for you. It's not easy for you to diagnose these things. So this is why we gave you a topology view. You just go click, it's a single click operation. It brings you the entire topology. You can find out what is connected where and see if there's any issue in connectivity. Going back to diagnostics, like I said, this is a suite of tools we have provided. And these tools were primarily developed based on feedback from you as customers. And very importantly, we coordinate very closely with the customer support team to understand what kind of problems you face. And we have kind of prioritized our feature set so as to suit your needs. As an example, we know packet capture is very important, but try to do a packet capture in any other cloud provider, you have to go install an agent and start it and collect it and so on and so forth. Here are just a few clicks. And the beauty is it's a variable packet capture. What it really means is that you can define your packet capture based on a given duration of time or the number of bytes, or you could also have advanced filters, for example, like based on a source IP or a source port, destination IP or a destination port. So it's very, very versatile based on what your needs are. Very importantly, it also stores it on a storage from where you can access. And you can easily click down and view it with any other open source tool that you have at your disposal. Likewise, there are many other tools. For example, if you want to understand if there's any route black holing happening, you just click and you'll get the details of where the route is getting black holed. Or if you find that there is a flow being denied, right? You're trying to access a website and you find that it's not accessible, you just go to the portal and enter all these details like what is my source, what is my destination, and what are my ports. It'll tell you whether it's blocked or allowed. And it'll tell you exactly what rule is blocking it or allowing it. This way, it's very, very versatile for you. The important thing is that all of these things are available via APIs and also available via PowerShell, CLI, and everything else, not just Azure portal. Now, the beauty with making it available with the API is that it makes it a very fantastic programmatic experience for you. You can create a whole lot of proactive and reactive monitoring situations. For example, we have something called Azure Functions. So let's say you have a VM, and a VM has a lot of TCP connections, and all of a sudden you're seeing the connections going down. You can basically set a trigger, an alert saying that if my connections go down, call an Azure function, call the API to do a packet capture. So you know readily on hand that you're able to capture the moment of the fault right there. Or for another example is you have a lot of packets increasing. You have attacks on your ports. And you find the number of data that's going through a port is increasing. As an example is data exfiltration. There again, you can do more of proactive diagnostics and monitoring where you can use Azure functions to go and capture all this data. Or you can also do Azure automation and create batch mode. You can kind of work in the background, use these APIs to go and continually monitor your system. So it's extremely versatile. Monitoring is very important. Think about finding if your VM is reachable or not reachable, right? We came up with this really good tool. You go to your website. Again, everything is accessible over CLI, API, and whatever you call it, right? You go to the portal and you just enter the parameters that you want to reach, right? It could be a VM to VM communication, or it could be a VM to an on-prem connectivity, or it could be a VM to, let's say, an external endpoint. You enter all this data there. You click on Check My Connectivity. It'll give you the hop-to-hop path. It'll give you the hop-to-hop latency. It'll give you the minimum latency that it took to traverse the entire path, the maximum, and the average. Not just that. Let's say you configured accidentally a security rule to block a port. It'll tell you exactly where that path is blocked. So we execute these heuristics on your behalf. We save you the trouble of doing all these diagnostics, and it's just a single-click operation for you. Logs. Logging is a very critical need. A lot of people who consume logs and generate a lot of fantastic data there in the market today. But try enabling logs for, let's say, 100 security groups. How do you do that? Or let's say you have 100 NICs and you want to enable logs on those things. So you need a single pane view. You need access, ease, and flexibility of how you can go configure these logs, enable, disable these logs at a mass scale when you want and whenever you want. So we've given you access to that as well. We also debuted something this week called Log Analytics. As a first case, what we're doing is we're consuming all your flow logs, energy flow logs, and we're creating some fantastic visualization experience for you. This is available today for private preview. I would encourage you to join the private preview. And we give you fantastic data like, who are the top attackers or top talkers of your particular network. You can see malicious ports being, malicious access happening, or you can see ports that are being compromised. So a whole lot of great experiences available. This is as far as Network Watcher is concerned. Now, besides that, there are various other tooling that's available within the Azure portfolio. So that's an interesting part, as well as it's unfortunate because of the fact that you as customers have a lot of difficulty in trying to discover them. As an example, there's something called DNS analytics. How many people have heard of DNS analytics here? So there you go, one person in the audience. So that is a problem. I'm sorry, it skipped ahead. So with DNS analytics, the thing is that it basically helps you access and find out details about what kind of server capacity is being utilized, and what kind of websites are being accessed, and so on and so forth. I think it's a time slide, unfortunately, but that's fine. So anyway, so we have this suite of monitoring tools that are available. Our North Star and primarily our drive is to make sure that we converge all these tooling under one service called Network Watcher. So very soon you will see that happening. Slowly and steadily we will be bringing all these tools together, primarily for two reasons: to give you better access to discoverability, that's number one, and number two is to have a very seamless and consistent experience for you, so you don't have to have different kind of tooling experience or API experience across different surfaces. This is our third-party and open source ecosystem. We started with a couple of them, but as you can see, it has rapidly expanded, and we're very proud to have 3 of them available today, very newly minted over the last 3 months. We have Gelata, and we have Gigamon, and we also have Greylog. And we are working with many more based on what your needs are and what your requirements are. We'll continue to work with many more. So we talked about a very high level in terms of what is available, what artifacts are available for you to go diagnose problems. Now, Abhishek is going to come on and talk about how he can take a customer problem and figure out what is available at your disposal to go needle through and understand what the problem is. Abhishek?
Thanks, Vijay. Hi, good morning, everyone. My name is Abhishek. Before I begin the talk, can I have a show of hands of people who have workloads running in Azure right now? Excellent, the dedicated few are here. And people who are planning to migrate to Azure? Thank you. And who all over here are just, very brand new to Azure, just trying to get a sense of what it is? Okay, nice, thank you. So, the way that I've structured the talk over here is we'll begin with a simple website kind of thing. We'll evolve, we'll use the resources and other monitoring capabilities that Vijay talked about, and see how all of these integrate together to provide a holistic view for your monitoring needs in Azure. And the whole journey, and before I go into the talk, I would like to walk you through the basic constructs that we'll be using so that you get an idea of what I'm talking about and as we go through it. So when it comes to monitoring, one second. Okay. So Vijay talked about a lot of things, and I want to show you as to how they actually fit in together, how they work, how they actually are in action. So I have over here with me, the first thing that you would need to go is the dashboard itself. So whenever you log into your portal, you are shown a dashboard over here. We highly recommend that you use this dashboard where you can put all your metric information that's coming from each resource into a unified view so that you get an idea of what's happening in your environment. Things like over here, I've got availability signals for my public IP, the byte count, the SYN count, and similarly for my CPU. The other thing is, so the way you would like to add these metrics is if you go to Azure Monitor over here, you can select your metrics. Over here, I've selected my simple website as one of my VMs. And you can pick and choose what kind of web metric you want to see. And all you have to do is just go pin to the dashboard, and it will be available for you for your reference. Similarly, when your Network Watcher is another tool that we talked about. This is the interface for it, where we provide you a whole bunch of diagnostic capabilities, as well as advanced logs that we'll walk you through. And these are the things that we'll be using through the session today. So to begin with the session, I've picked up a theme of a website. We will start by creating a very simple, fundamental, bare-bone website. And as the need and requirement increases, we'll start to add more resources that Azure provides and see how we expand on it. And the intent being that for each of those scenarios, to showcase what we provide in terms of monitoring, what are the common pitfalls, and what are the things where you find things are broken, and how do you go fix them, so that it gives you a holistic idea of the capabilities and also gives you a directional indicator of what all you can do with this platform. So to begin, let me show you what I have as what I consider as a simple website. So I have a resource group over here, a simple website. And in this, to create a website on Azure, all you need basically is a virtual machine that has a NIC. And now since you have a NIC, you connect it to a VNet. And then I have a public IP connected over here as well, so that people can reach onto this website. And finally, you need a network security group so that you can protect your network. You don't want, so that you can restrict it in a way that only certain flows, certain IPs and port combinations are allowed, both inbound and outbound. So let me switch over to this view. So this is the same website what you saw. So let's start with the public IP itself. And what kind of capabilities do we provide you? The first thing over here is the availability, which tells you whether the signal is up or down, whether my public IP is available. Now, what does that mean? So the idea over here is to also show you what kind of metrics are there and how do you interpret it. If you don't understand what the metric is, it will be very difficult for you to take any actions on that, right? So over here, this is the live metric over here. And what we see is whenever the availability is up, what it essentially means is that your public IP is connected to a particular NIC. What we are doing behind the scenes over here is making sure that any packet that reaches your public IP is able to successfully go on and reach the platform so that it can hit the NIC. Now, in certain scenarios, if you have not associated any public IP to your NIC, your availability is this is one of the conditions when you'll see the availability all down. So that's an indicator that either you check the public IP is connected back to the NIC, or is there a problem with the platform at that point. Along with that, you can also take a look at the byte count, the packet count, so you get an idea of how heavy the traffic is, and similarly the SYN counts over here. The second component in my thing is a virtual machine. So VMs, as you saw, we have a whole list of metrics that you can function on. Over here, say, for example, your CPU, your network in and out, your disk write, and things like that. Now, whenever you have a metric and you know, OK, I can measure it, the natural thing is, good, let me know when something breaks or let me know when something happens, right? For that, the easiest thing to do is all of you want to do and set an alert. And that's the basic thing that you would like to do, and that is what we recommend. Now, the point is the alert system over here also provides you a lot more things that once an alert is fired, what should it be doing? Should it send you an email? Should it send you a text message? Or is it possible for us to create a scenario where an alert is fired and I want to take an action on it? I want to do something constructive, right? Or I want to get more diagnostic information out of it. So for that, what you can do is you can integrate it with, say, for example, the diagnostic capabilities that Network Watcher provides. To see that in action as to what we can do, let's take a look at the same alert that I have over here. So for alerts, you go onto your Azure monitor over here, where you can see all your alerts. I'll select my subscription right there. And you get your resources. And this is the alert that I'm talking about. So in this particular case, like Vijay was talking about earlier, is how you can initiate certain actions using serverless compute and Azure functions. What I have done over here is I've got a webhook configured, and we've got documentation around it as to how you can do it and what all you can do. And whenever the alert gets fired, this particular webhook is actually initiated. So something of this sort, let me just initiate it for you and see what it does. And we'll proceed with the presentation in the meantime. So once you've done that, what it'll do is, what's happening behind the scenes is that it'll go and trigger a packet capture for you and also send you an email with a link to your capture so that you can open and diagnose it. Further down the session today, you would see, and we've got two partners over here, would also show you how you can consume this in your environment and make more and extract more analytic information out of it. So moving over to the next resource is Nick. Nick, again, we provide you things like bytes and packets to give you more idea of what it is and how you can measure how much traffic is coming in or not. Now, this is a simple website. You would assume that everything is fine, everything is good, and I've got my IIS, say, for example, set up over here. Website should be running fine. But one thing we might forget sometimes is the network security group. There are certain default rules that it comes with, and one of them is deny all inbound traffic, just to protect you so that nothing happens. So in some cases, once you have done all that, you would just go and say, let me go and see what my website kind of looks like, and you will find that it's not reachable. So what we recommend is, one of the diagnostics tools that we provide is an IP flow verify. What it does for you is, here you can pick up your NIC, and you can say whether a particular inbound flow would be allowed or denied. And it also tells you which particular rule of the network security group is actually allowing or denying that flow for you. So this is all about the metric and the diagnostic information. We also provide you a rich set of logging, and that is called the NSG flow logs. What you normally don't see is anything that has been denied is something that those flows don't hit the NIC. If they don't hit it, you don't see it no matter what you do, right? So you need something which can actually tell you how many flows, which is basically a source port, an IP, and a destination port and IP, were actually directed towards your NIC, and how many of them were actually denied. Because you would also be interested in, is somebody trying to get in and my rules are working at that point. So for that, you have a network security group flow logs is the thing that we have introduced. So once you enable it, all these logs go to your storage, and there are various ways in which you can consume these logs. One of them is through a Power BI interface that you can do that. If you have an open source, we have also got a lot of open source integration, so you can see it in Kibana if you want to. And also with our analytics service, that is, we are starting the preview for it, where you would have a very rich interface about what's happening, who's my top talker, where the session is, where the packets are coming from, right in the portal itself. And just to give you a view of what it means, so let's see how what you can actually gain from it, what insights can you get. So for the same network website, I have this NSG, and this is the flow by decision. So initially, when the port was closed, it was all open. You would observe that there's a lot of allows happening, and the reds are denies. Then I realized that I've left my port open. Everything can come in. And then I said, no, I should just restrict it to port 80. And then I started seeing more denies coming in. You would also observe an interesting thing over here. These are the destination ports. So does this thing look familiar? I have a public IP, and all I want is a website. But then you realize that somebody is actually doing a port scan right over there. And that's where the NSGs come in and help you. The same situation can happen on your network itself. And these are the rules that will help you to identify what's going wrong in your system. So moving over to the next one. So these are the metrics that you can look at. The idea with this talk is that next time when you go and reference it, you have got all the information required, and it's a good refresher for you as well. So I've got a simple website. Everything was going fine. Now all of a sudden you realize there's a lot of traffic coming in. Then how about I put a load balancer into the mix, right? Now, so this is what the topology looks like. And the same thing, I have got two VMs now that are load balanced behind. I have got a website load balancer over here, and then I have the front-end IP. So that now, let's see what we can do over here in terms of metrics. So we have VIP availability, that was what you saw. We have dip availability, byte counts, packet counts, SNAT connection counters, sync counts. So you've got all that information coming over here. Not only that, we've just launched, these are called the multi-dimensional metrics. So if you want to look at the VIP availability for that particular VIP or a particular VIP port, you can actually customize it. Similarly, in dip, it could be on a protocol type, dip port, VIP addresses, and a whole bunch of things over here. So the single metrics that we have, you can slice and dice the data based on your needs and use it. Now let's look at the dip availability, what this is all about. So the load balancer has got health probes in it, right? And these are the guys who go and check if everything is working fine or not. And sometimes, if you're monitoring it, you would find the health probes are all down and then there's an up. So what does this 0 and 1 in a health probe kind of mean? So what essentially we are doing is we are checking this connectivity in the backend pool, if the backend pool is successful or not. So this is the way that you would interpret when you look at the dip availability signals. So if you're monitoring your site, it's advisable that you look at both your VIPs and dips so that you know that the health of the connection is there, the packets are flowing in. And similarly, your packet count and byte count are also a good indicator of how much the traffic flow is coming into your system. Then, okay, so now let's say that I have got everything set up, I'm good, but I need to log into my VMs and I want to go ahead and install my IIS server. The first thing I would like to do is RDP into my boxes. And if you worked over here, you would be familiar with this particular thing which says cannot RDP into my session. What we need to understand over here is that since all these VMs are behind a load balancer, so you would also, you need some NAT rules so that when you're connecting to 3389 for that particular IP, you should be able to direct it to the right VMs behind the scenes. So we advise that if you encounter one of these, it could be that the network security group is blocking your traffic, or it could also be that you have not got the inbound NAT rules in place. So once you have that in place, you would be able to successfully go into the system at that point. Now, so I find this thing, I've got my website, everything is going on fine, but I realize that a lot of my customers are coming from different regions, and I want to make sure that the latencies are good. From there's in Europe, there's either customers in US, and I have a website, something of that sort. Now, how do I, mature this website a bit? So for that, let's take example of a traffic manager. So traffic manager is a service which lets you send packets based on which you can either route your packets based on geography or performance, and there's a whole bunch of things in it. And then what I've done over here is I have a traffic manager which takes it from region 1 to region 2 based on where the origination of that source is. And in case of traffic manager, we definitely provide you with the endpoint status. We also give you the queries by endpool. So you can get a sense of which region is the traffic coming from. So say, for example, in this case, if I have one of the regions where I have my website is in US, the other one is in Europe, you can get a very good idea of how the traffic is flowing in and where you want the loads to be. And on the back end, what I have over here is an application gateway, which is, again, balancing my traffic on the inside. So one of the things that we need to look at when we are monitoring it is the endpoints. So traffic manager, if you go there, it'll give you a status of your endpoints again, which is important. So if your endpoints are not up, then essentially you won't be able to route. When customers are coming in, it won't be able to route it to the right points. And this is what it kind of looks like if you're monitoring it with a graph. And whenever you see that the endpoint is, that the metric says 0 for your endpoint status, what it means is that there is no backend response coming. But if there is healthy, there's a backend response that's coming in. And these responses are configured from your probe that we have over here. So what you can see is on port 80, I have got my monitoring settings right there. Now, there could be a number of cases where the backend is not responding. One of them could also be a network security group rule that has been configured on that particular port where we are denying all your traffic. So even though your platform might be healthy, the probe might not be able to successfully communicate it back to you. So let's take a look at application gateway now. One of the key metrics that we provide is the throughput. So you can get a sense of what is the throughput that's coming over here. So you know, again, on the gateway side, how it's happening. Along with that, application gateway provides you a rich set of logs. And this is interesting. I mean, you've got access logs, you've got performance logs, you've got firewall logs, and the consumption of these logs is very simple. So what I have over here is your latency and throughput graphs over here for my application gateway. And to get this particular graph to see how things are, all I did was I went into Power BI. That's one of the ways you can consume it. And you just point it to the storage location where you have, and you take it. Power BI is able to extract the JSONs. And what you get over here is all these fields over here. So you can see failed count, health host, instance, latency, request count. So this gives you much fine-grained control on how the traffic is flowing and if there is any decision that you would like to make on that. So moving over. Now, let's add a little bit more complexity over here. I want my application gateway VMs, the backend VMs, to sync between two regions. You know, I don't want the same thing, you know, upload data in one, and then on the second one, I want these two guys to talk to each other so that everything is in sync. For that, what we have over here is the virtual network gateway. That's what we're using, right? Now, this can get complicated to monitor and measure. So we provide you with a whole bunch of metrics again. You can have tunnel bandwidth, peak bandwidth, egress, ingress, you name it, and it's there for you. So this way, you can monitor your system in a very precise way and get all the relevant information. So since it gets complicated to monitoring is fine, but what if something is wrong? How do you actually go identify if something is wrong with my gateway or the connection that you have established? Right? In some cases, your gateway might be connected to the on-prem too. So how do you go about doing that? To simplify that effect, what we have created over here is a VPN diagnostic tool. So all you have to do is you just select your VPN, specify the storage so that we can put all the logs that we find for you over there and just run it. Once you do that, for gateway, there's a bunch of faults that we discover for you, right from if there's a planned maintenance going on in the backend, you'll know it, right? Or on the connection type, if there's an IKE policy mismatch, say for example, or a pre-shared key is mismatched. So we will identify all these things for you so that you can make the right decision and focus on solving and fixing the problem at that point. We also recommend that you can also run it in a continuous fashion using either Azure automation so that it's being continuously checked every hour or every 5 minutes, and you can do that. So now we've got all this. How about we make it a little bit more interesting and add on-premise to the mix as well? So I have got my data that's syncing from my cloud. At least we got the cloud sync going on really well. I want to do sync on my on-prem as well. So I want to make changes over here on my on-prem. I'm using ExpressRoute over here. And I want this backend to sync on-prem, and then everything else has same. So the backend remains the same so that everybody, when they access the website, they get a similar experience for the core things that I'm going to launch. So for ExpressRoute, you got things like bytes in and out so that you get to know, how much traffic is flowing in. And along with that, the connectivity itself is a bit interesting on ExpressRoute. And how many of you are using ExpressRoute circuits over here? Excellent. So, and you would have seen how do you go about seeing connectivity, is my circuit up or not, or if there is something that's missing. And the first thing I want to see is that can I reach from my VM on the cloud back to on-premise? So what we have over here is the same connectivity check that we had introduced in preview, lets you do that. So you select a particular VM, and you specify your destination over there, which happens to be my on-prem VM. And what we do for you over here is, if you can see closely, we say that it starts from your NIC, it goes on to your gateway, and from there it takes two paths. So the Microsoft Edge has got two paths. From there it goes to the customer edge, and finally to the destination. If we identify errors in any of these conditions, where a packet is unable to reach, we would also notify you. Like in this case, we found no issues on the path, and only there was no response from the destination. So we give you a warning saying that everything looks fine, but it seems that there is no listener for a particular port that you have configured over there. It could be another case where routes for the destination are missing in the virtual network gateway, right? And this is when I was just trying it out in the hotel, and I just put my IP that I got there and see if I can express route would go there to my IP that I got on the public network over there. So for that, it gives you, no, there is a problem. There are no routes configured for that particular endpoint. Similarly, it will also tell you if there is a NSG rule that's actually blocking. So you got your connectivity going on fine. Everything, ExpressRoute has got no problem at all. But the problem lies with the network security group rules that you have configured, which is not allowing traffic to go on that particular port. So in one single shot, when you run this check, you are able to see each and every hop and able to identify what's missing and what's wrong. Now you're saying, yeah, this is all good. I can do a connectivity check. Can I continuously monitor it as well? Can I do that? Well, yes, you can do that too. So in that case, with Network Performance Monitor, you can actually start your monitoring, and there you would see a trend at that point as to how things are connected. And if at all there is a problem on any of those links, it'll point out that there's a problem. So the way we are looking at connectivity is in two phases. One is, am I connected? And the second thing is, what's broken in that? So our goal to you is to provide you, yes, you're good, no, you're not good, the connection, not you in person, but why is that connectivity broken? So our main goal is to answer the why for you. With that, let's take a look at what kind of scenarios we face when we talk about connectivity. First is things like this. These would be some of the common things that you would have seen in your environment. Destination is unreachable, so you don't know whether it's a platform or a configuration problem. That's the first thing. Is Azure doing fine, or did I do something over here that's not getting me what I'm supposed to? Then you go in there and you say, okay, my source looks good, my destination looks good, but still I can't talk. I've got everything configured. The route goes from my source, good. I'm able to have no network security group rules that are blocking it. My firewall is not blocking it on the source and destination. However, your packet can take multiple hops as it goes through, and each hop you would have applied either a network security group rule or a UDR, the user-defined routes, and they might take your packet somewhere else. So how do you identify those problems? Is a connection sluggish? How do you do that? Can I get to know which hop has a problem with the latency so that I can focus on that particular hop and try to optimize it? Now, VM is unable to reach the machine, or it's unable to reach any Azure service endpoint. I want to reach I've got a SQL instance that I want to reach to. Can I do that? And this is what you can achieve with a connectivity check, is what we've introduced for you. Not only you can select any source VM that you have, and for your destination, you can either specify a virtual machine, or you can specify anything manually. And when you go into the manual mode, you've got URIs, FQDNs, and IPv4. So basically, it opens up the whole gamut of anything that's addressable on the web. You can check the connectivity of your virtual machine in Azure to that endpoint. It's as simple as that. Say, for example, in this case, if you observe the highlighted point where it says the status is red, it's telling you two things over here. It's telling you that the traffic is blocked to the following rule. There's an inbound rule that's blocking traffic. And it's like, okay, fine, if the inbound is blocked, as well as if the packet would have reached on the VM, you've got another outbound rule, again, that's blocking the same port. So it's advisable, once you get the message, you can go back to the NSG and you can say, okay, let me just fix these two rules and things should be fine. In some cases, you don't want the connectivity to be there, and you want to check that, the rules are active, which are blocking the traffic. This comes in handy as well. If you don't want two VNets to be talking to each other, you check this and you say, this will also give you an idea that the rules that you've configured are all the right rules, and the connectivity is how you thought it would be. And there's more, so I can just quickly show you how it looks like. One second. Oh, by the way, I got this email, so let me just open this for you. So this is what I was talking about when we initiated the captures at that point. So the event is complete. I have got my virtual machine, the website VM, and here's the URI for that capture that I received. So this is the alert that got fired that I had set up earlier. Oh yeah, there we go. And when you click the file, so this is what you get. So now you have your captures right there with you, and you can see how they can be addressed. So this is one last thing. So this is the check that we did, that we were showing you. So here is the connectivity check at this point, and you can specify your virtual machines. You can select an FQDN if you want to. Once you click check, in this case, it's reachable, and you can see that I'm checking on 3389. Earlier, I was trying to reach out on port 80, and that's why it was saying that it can't reach. But once you specify, I've opened up my RDP port over here, and then I'm able to go and reach to that destination, and there are no errors that I've found. So with that, and this is, again, I'm trying to reach out to the internet over here. I'm going to Bing. And you can see we also give you, once you leave the NIC, even the hop-by-hop latencies on the internet, as well as all the paths that you would observe. If it's taking multiple paths, you can actually get it from this single API. The interesting bit over here is that all these APIs, all the diagnostic tools that we are providing, our promise is that it will be available through REST, PowerShell, CLI, SDK. So if you want to integrate with any subsystem, any third-party tool, or open source integrations, you can seamlessly integrate with it. So if you're using any tool, we want that you should be able to integrate and have a richer experience so that you don't have to go through learning curve, or if you already have a process in which you are using these third-party tools, we should just seamlessly integrate into that. So with that, I have Shesh over here from Gigamon, and he would talk about how you can integrate this information and get more value onto the platform. Thanks.
Thanks, Abhishek. So just a quick show of hands. How many of you have heard of Gigamon or used Gigamon? Good, thanks. So we'll walk through, Abhishek talked about some of the connectivity issues and how you troubleshoot them. But let's double click a little bit deeper about how do you get continuous visibility itself as to what's going on in your Azure VNets, or even in some cases, some of you seem to have used ExpressRoute. How are you looking at that as you back all the traffic back to the on-premises? So I'm Sesh, I'm Director of Products for Gigamon on the Cloud Solutions. So just a quick overview, founded in 2004, pioneer in network visibility. Our mission has been to provide continuous visibility for traffic, whether it's on-premises, private cloud, or public cloud. We are a multi-cloud solution, and we work with eco partners, a lot of ecosystem partners. Some of them Abhishek and Vijay already talked about. They're in that slide, so we work with them as well, feeding traffic into those tools for analysis and monitoring and visibility as well, in various verticals around the world. So why? What's the big deal about visibility? So this is a picture of a shared responsibility model that as customers, you have certain responsibilities of protecting and monitoring your data in the cloud. Abhishek talked a lot about how do you monitor them. That's great, but you also have your responsibility of protecting them, troubleshooting them, analyzing them as well. So how do we get into that? How do we look at that from your perspective, and what are the tools that are available to do that? And how do you get network controls and some of the services around that? So some of the priorities, and I'm sure most of you are in these two categories, whether you're cloud ops or SecOps or NetOps, IT ops, there are a lot of ops, no ops, for example. But you have your responsibilities to run mission-critical applications in Azure, apply some of these compliancy controls from a security perspective, or mission-critical applications. And also, it's more than identity and access management. It's not just about controls. It's also about visibility into that traffic, specifically around network security, right? What are the impact if you don't, for this kind of value is network security stack is essential, right? Malware protection is good, but what about detection and response as well? Packets never lie, right? You need, the more you see, the more you secure your networks and your workloads as well. And to mirror this traffic, you cannot have multiple agents running on these workloads because there's an impact to the application and the cost of the application itself. So how do you optimize that? So these are some of your priorities that you might be thinking as you migrate your on-premises mission-critical applications into Azure as well. Does this sound familiar? You're spending more time and resources deploying and managing, and then you're running many VNets in the on-prem, in your public cloud, and how do you get centralized visibility and security as well? So we did a quick survey of some of our customers, or some of industry enterprises, and again, 91% said they want identical visibility and security to what they have in the on-premises in the public cloud as well. So no surprises, as you're moving your mission-critical workloads, you want to make sure that security posture and then the application networking posture remain the same as your workloads migrate. So let's take some of the application. Abhishek showed an application. Let's take the simple application here. The way we look at it is there are some hotspots, right? I mean, we talked a lot about connectivity hotspots, but there are some north-south hotspots ingressing and egressing into your VNet, and also east-west hotspots within the application itself, right? So how do you secure this network traffic in this application instance? If this application was in your on-premises, you're doing a variety of ways to get access to this traffic to inspect and secure that. So how the Gigamon solution works is we have a light footprint agent running in the application. You extract the traffic once, because we all concede that there are going to be many monitoring and security tools in the cloud inspecting the traffic. Could be your SIM, for example, could be an APM, for example, could be an NPM, for example. All are looking at packets for analyzing the traffic. And how do you rather than installing an agent everywhere, why can't we just get it once, aggregate that traffic in the visibility tier, and then we will make sure that all the tools that need it get it. Think of it as you have a fire hose of traffic coming from your application, and you want to make it into a faucet for each of these tools so they can inspect what they need. And that's where the solution helps. Some of the APIs that Abhishek talked about, we will use those APIs into Azure Monitor or Azure APIs to get the VNet information, the VM information. So we are automatically detecting new VMs as this application scales out. So all this is captured here. So minimize the agent overload. You aggregate, optimize, and distribute the traffic to the tools you need. The intelligence to reduce the overload. For example, let's take a security tool and an application tool, monitoring tool. A security tool might need everything. They might need the fire hose because they can't trust just part of the packet. They want the whole thing. Whereas an application or a network performance monitoring tool may just need 1 in 10 packets. So we can make sure that we give the right set of packets to the right tool. Right? Again, automatic traffic selection. As Azure Load Balancer spins up new VMs because the applications scale out, we will automatically detect that and then make sure that traffic is acquired and sent to the tools based on the policy. And then also API integration. It's all about APIs. We all live in the world of automation and orchestration, so we have a rich set of APIs working with Azure, as well as our own northbound APIs for you to automate this as you deploy new VNets. But it's more than a simple application. I mean, Abhishek walked through some of the complex applications. You're more than likely going to have multiple VNets that are going to be connecting in. Rather than putting these tool tiers everywhere in each VNet, you could centralize it. I mean, some of you are SecOps and Cloud Ops. There's no reason to put these tools everywhere. You can centralize these tools in your security ops VNet, and then let all the traffic be inspected there. So you control that domain of these operations and visibility. But if you have an on-premises application to backhaul back into your on-premises with your express route, so be it, right? You can still get the traffic out of your VNets, right? Land them in the visibility platform in your on-premises, and then all your physical tools that you've already invested in can still get access to the same traffic. So the bottom line is you're not missing, as you move your mission-critical applications into Azure, your inspection, your security analysis, and security posture can remain the same. The quick benefits, identical visibility in Azure as well as in on-premises, complete network visibility for all the workloads and VM traffic in Azure, centralized monitoring, so if you have a SecOps that is invested heavily in tools, and you get the flexibility to make the decision of the tools. We work with 100+ eco partners, including some here. Again, if you want to run mission-critical workloads as you move from in your digital transformation, you're running mission-critical workloads with security controls. Then again, for the performance analysis anywhere, on premises, in the cloud, doesn't matter. So quick for information, we are in a preview. Abhishek and Vijay talked about it. We just announced it at Ignite. We are targeting for beta in December. Then if you have more questions, Kirk and I are here. Please stop by and talk to us, or you can go to gigamon.com/Azure. With that, I'm going to transfer over to Gelada. Charles?
Thanks. Thanks, Sesh, for a great presentation. It's really great to be here. I hope everybody had some coffee because I'm going to get a little technical on you. I'm very excited today to present some breakthrough technology that Gelada has done specifically for hybrid cloud network monitoring and optimization. It's called Gelada's TrueFlow. TrueFlow, for the first time, gives you the ability to visualize, find, and fix infrastructure issues in the hybrid cloud environments, both on-prem and in the cloud. We work hand in glove with Network Watcher to provide unprecedented visibility and unprecedented resolution. We see what other tools miss or can't see at all. And we've been deployed with a Fortune 200 company at over 80 physical sites worldwide, their offices and data centers. And now with Network Watcher, we're moving that visibility to the cloud. We've been fortunate enough that they call our service Bing Search for your network. We provide predictive maintenance capabilities like baselining and anomaly detection, security features in finding DDoS attacks and port-based attacks like WannaCry. We do performance monitoring and find network infrastructure issues like overloads, misconfiguration, network bottlenecks, and we help you distribute your loads and balance them for network optimization. So in the cloud, of course, you have your physical offices. In our case, we're at San Jose, and we have other offices and data centers. And we've deployed in quite a few of the Azure cloud regions, East, Central, West, so on and so forth. When there's an issue in the past, the admins would go in, log into the VMs, try to find the various log files, maybe take packet captures that we've been talking about, and then trying to fix them by themselves or try to correlate them. The issues are multiple locations, it's a lot of work, multiple OSs, they're not just all Linux or Windows. And then the issue is, if you don't know the time, how do you know when the problem happened or which problem happened first? So it's really important to solve all three of these problems. And that's exactly what TrueFlow has done. We use machine learning techniques, we use AI, we automatically resolve topology issues, timing issues, and TCP reassembly issues that are really pernicious from keeping you from understanding what's happening in your network. So what we do is we work with Network Watcher CLI 2.0 to initiate the captures at the desired VMs. We also coordinate those with on-prem captures, and clearly we can work with the Gigamon, GigaView captures to be able to bring all of this information, the individual captures and packets, to a Gelada TrueFlow VM running at an Azure site. We process, we synchronize, we correlate, and we merge all those captures into a single capture that then we analyze. We can get for every site, every VM, every flow, throughput, loss, latency, jitter, packet counts, and flow counts, and we present that to you in a nice, easy-to-use UI that you can explore so you can understand if your network has been performing or underperforming at any point. So for today's demo, I have a demo video. I'll take you through that. It's a 4-node site, virtual network that we set up using 3 Azure sites, East, West, and Central. And we are connected through VNet. And we also connect to our physical site in San Jose. And we've done that by connecting to the mesh using a Juniper Networks VSRX firewall. We're going to go through 3 cases. High throughput elephant flows that stomp on your network, bottlenecks in the network, bad topologies that really strangle your application performance, and then we're going to block a rogue flow using Network Security Group. And we'll go through the video. So first I'll introduce the UI. There are several sections of the UI. on the top right, what we see is what we call a chord view. It's a patented view where we can see all the VMs in one picture. And from that view, we're able to find issues. Let's say highlighted in yellow, we're seeing a latency issue from Gelada actually going into Gelada, and it's coming from all of the Azure sites. But the flows that are marked in gray are the Azure flows, and they're all fine. Now below what I have is our spatial view, and the spatial view shows the VNet mesh. And what we can see is we can see not just point metrics, but segment metrics. From west to east, we have 22 milliseconds of latency, and from east to west, we have 16 milliseconds of latency. Now you can see at the Gelada VM, we're having an issue where all the flows coming in are marked in yellow. This gives you an idea that all the flows that are marked in yellow are pointing towards Gelada. We have a problem coming into Gelada and not in the Azure cloud. Next thing we can do is we can go down to what we call a temporal view, very, very detailed view, like an oscilloscope trace, let's say, where you can see in 100 millisecond windows what's happening in the network for any two segments, any two sets of flows. What we can see is bidirectional metrics or unidirectional metrics. Bidirectional metrics are shown pointing up, if they're upstream, and downstream are pointing down. In this case, we see one big monster flow, what we call the elephant flow. So we'll dive into that. So it's very easy. You take the UI, all you have to do is zoom in on it, and that will dive into what we call our analytics mode. In the analytics mode, you can get unbelievable amounts of information. Here we're seeing 350 megabit per second elephant flows, and we broke them down into individual flows, and there's two specific ones that are at 48 megabits on average. So you can see exactly which flows are causing the problem. You see the IP source address, destination address. These are TCP flows. You can see the source port, destination port, and the quality of service for those particular flows. And then below, we're showing at the same time correlated the loss. You can see that the loss is really well correlated with the TCP flows. So not only is it a lot of bandwidth, it's causing a lot of loss at that point in the time. I'm a little ahead. There we go. So in this case, there's about 2.5% loss for this particular link. All right, so now what we're going to do is we're going to find application topology bottleneck. So what we did is we took the same two file transfer flows, and what we did is instead of doing them in the Azure cloud point to point, for some reason we had decided that we were going to take them through our office in San Jose. When that happens, you can see at the top in the throughput that we have less throughput than before, and it's taking a lot longer to do these file transfers. So in this case, before it was 10 seconds, now we have 90 seconds to do this file transfers. And you can also see pointing downwards, we have a lot of latency coming into the Gelada site. So we can dive into those flows again. For that particular capture, we find that there's flows coming from, going from Gelada to west, Gelada to east, and then from Azure Central to Gelada, and Azure East to, and Azure Central also to Gelada. So the problem is, because we've taken those flows instead of point to point, we've brought them through one point, we've created a bottleneck, and that's causing a problem. And then below we can see, again, loss, but the loss is not for the TCP flows. Your TCP flows have actually caused you problems with your UDP traffic. And why is that important? Because UDP is usually your voice over IP or your Skype traffic or your other conferencing traffic. So your file transfers are actually causing the bad performance for your voice. So you have an option here. What you could do is you could put your voice calls on a higher quality of service and reduce the loss. So the next thing is blocking rogue flows. So what we did is we did the exact same file transfers, but with Network Watcher NSG, we blocked the specific port from the central site, so no longer could that transfer happen. So we did it exactly in the middle of the transfer, and that's why you can see that the transfer didn't take as long, because we actually blocked it and cut it off and improved the performance. So the other things that you can see at these times, you can also see jitter at the same time. So in short, what we've done is we've done a demo of a 4-site hybrid cloud VNet mesh, physical site with the 3 Azure sites. We help you find the elephant flows, identified the topology issues, and we blocked rogue flows. And if you want any more information, I'd be glad to talk to any of you after the session. Thank you.
Thank you, Chop. Really appreciate that. Nice presentation there. Thank you for taking the time to be with us, and likewise, Sesh from Gigamon. So I think there's one common theme. I just hope I can go back to the clicker. There's one common theme. As you move all these workloads to the cloud, you are going to be needing a lot of tooling. You need a lot of visibility. You need a lot of insights to how your network works. And the only way that can happen is you give us constant feedbacks on how we can improve the product, and we can invest on not just the breadth of what information will be made available, but also the depth. So far, if you look at what has happened over the last 12 months or so, we have, on a very comprehensive basis, addressed both these areas. The second thing is about discoverability of network monitoring tools and also having a consistent user experience. We're working on that. And we will make sure that any tool that we make available has a great experience for you, not just in terms of usage, but also to make sure that it's giving you the right benefits that you want. And we will continue to invest on our third-party ecosystem and also open source tooling. This is to ensure that you have a wide variety of tools that you have to integrate with and work with. So thank you for taking the time and being with us. Continue to give us the feedback and help us improve. Thank you so much.